Gravity is something very natural to us humans. Like any other force, we feel it. It pulls us down. But is it actually a force? Well, let's find out. First, consider two clocks that tick at the same rate. A light signal is sent to clock A every second according to clock B. And as they reach in 1 second intervals, we know the clocks are in sync. But now if the clocks accelerate to the right, the distance that each signal travels is shorter because of the acceleration. So the signals arrive in shorter intervals. Clock B ticks faster than clock A. But what does this have to do with gravity? Well, Einstein realized that the acceleration due to a force, like from a rocket, is indistinguishable from gravitational acceleration. He called this the equivalence principle. So basically, if you replace the rocket's acceleration with a gravitational field, time at the top still ticks faster. But all this is just half the story. Because you see, when an object falls, it moves through both time and space. We introduce a force called gravity to explain what pulls it down. But do you see what's wrong here? We learned time moves faster the higher you are, but here it's the same. Einstein fixed this by allowing Earth's mass to curve space-time near it. Now, for the same length, more time passes above than the bottom. Interestingly, the ball, although moving in a straight line, still falls in the house. The ball falls not because of a force, but because of its natural tendency to follow a straight line. Now, we only used 2 dimensions instead of the actual 4 dimensions of space and time because it is impossible to show all 4 on screen. But math can take us there. The general theory of relativity allows us to calculate how mass and energy curve space-time. For example, using it, we can show that a GPS satellite's clock gains about 39 microseconds for every 24 hours here on Earth. If this time difference isn't corrected, the GPS would accumulate an error of 10 kilometers per day. General relativity can also explain things that Newton's older law of gravitation couldn't, like how much light bends around massive objects, or why black holes might exist. Many experiments over the years have confirmed the theory to be correct, telling us that there is no force called gravity. There's just space-time, its curvature, and us in it.